Okay, as the smart board fires up here, you need to be taking out your outline. You need to get your notebook. We're going to be working some double replacement problems. You also need to have your activity series / solubility chart handy, because we're going to be doing some stuff with that also. If you look, your learning target today is the same as what we've been doing the last few days. It is to classify the types of chemical reactions. Now, in order to be able to do that, we need to be able to do the following success criteria. Number one, I can balance a chemical equation. Number two, I can describe / identify a double replacement reaction. Remember, one of the key parts is to be able to identify which type of a reaction we're dealing with. These aren't too bad because we've been breaking them up. We've done them all individually. When I throw 5 different types all together, it gets a little tougher, and you need to be able to identify which type we're dealing with. The third success criteria is to be able to predict a double replacement reaction. Given the reactants, we need to be able to tell the products. And finally, we need to be able to determine solubility using the solubility chart. So that's why I wanted you to have that solubility chart handy. Okay? So, when we talk about double replacement reaction, we have these 6 different types of double replacement reactions. What do you notice about all of them except for the first one? Who can tell me? What do you notice about every one of them? Kira? They are dealing with acids. Okay, so acid and a salt, acid and a metal carbonate or bicarbonate, acid and a base, which is a metal hydroxide, acid with a sulfide salt, acid with a sulfite salt. So all 2 through 6 are dealing with acids. Now, the top one, number 1, 2 aqueous salts, that is the only one that's not dealing with acids. And we have some specific rules to follow. So let's look at that on our outline. Okay? Where it says 2 aqueous salts, the rules we have, it says step A, we need to determine both possible products. So we are swapping the cations. Step B says that we need to check the solubility of both possible products. C says that if both possible products are soluble, then no reaction. D states at least one reactant must be soluble and aqueous to have a reaction. Now, that's just because if both things are solid forms, okay, they're not going to react. We're not just going to smash them together and it's going to be a reaction. So we need to have some sort of an aqueous solution. Now, today we're just going to say, take for granted, yeah, these are aqueous solutions. Yeah, they're going to, the reactants are going to be aqueous. And finally, we need to use the appropriate symbols. I do not like using the up arrow and the down arrow. What the up arrow means is that it is a gas given off. What the down arrow means is it's a solid precipitate. I don't like using those. I like using the parentheses G for a gas. I like the parentheses S for a solid. I like the parentheses AQ for an aqueous solution, a soluble solution. Okay? So we're going to see that we're going to use those as follow, and we're going to try to stay away from the up and the down arrow. Okay? Now, something that I have to tell you is if you don't do that last part, if you do not use the appropriate symbols, you're going to lose points, because we have to have one that is soluble Okay, let's check back up to letter C. If both products are soluble, no reaction. So we have to have at least one of those that is not soluble. And you'll have to tell me whether it's soluble, whether it's not soluble. Okay? And you'll see that here coming up in a second. So we're just going to jump in and work some of these. So let's go back here. And let's go right in here. I have strontium acetate reacting with calcium chromate. Now, once again, when we did these, I told you on the video, it was like AB plus CD, and it was going to yield, we were just going to swap the A and the C. So it was going to be CB plus AD. That was the general form. Okay? And I said, it would be like you're at the dance, okay? You're at the dance, and you're dancing with one person, and somebody else, another couple's dancing over to the side, and then you just trade partners. Maybe like a square dance or something like that. Okay? That's what this double replacement is. So we're taking our cations, and our cations are always coming first, right? So we're taking our cations and we're swapping them. That's the double replacement. So as I go through and look, I'm going to start out with strontium acetate. Strontium is a 2+. So strontium's a 2+. Acetate is a 1-. So strontium acetate right there. And once again, can you see how important it is to be able to write formulas given the name? It's very important. Okay? It's very important. Calcium chromate. Calcium, Ca is a 2+. Chromate is CrO4, 2-. So there are my two reactants. Strontium acetate, calcium chromate. Now, when I look at this, this is a double replacement. It is a double replacement number 1, because I'm not dealing with an acid, am I? So, as I know my double replacement number 1 here, I know that I have to follow those 5 steps, A through E. So I need to determine the possible products by swapping my cations. So I'm going to do it down below since I don't have any room over here. So I am going to have calcium acetate. Calcium's a 2+, acetate's a 1-. And I'm also going to have strontium chromate. And strontium's a 2+, chromate's a 2-. So those are my possible products. I need to check the solubility of both products. So I'm going to look at my solubility chart now. I got to find it. Here it is. Here's my solubility chart. So I'm looking first of all at calcium acetate. Here's calcium. Acetate's the very first one. It has an S. So that tells me what? It is soluble. So I'm going to come back to my sheet here and say, okay, calcium acetate, I'm going to put an AQ because I can dissolve that in water. It is an aqueous solution. Now I go back. My next one is strontium chromate. So where is my chromate? It is 1, 2, 3, 4, 5 over, because I got to go all the way down here to find strontium and go 5 over. 1, 2, 3, 4, 5. It gives me an I. What does I tell me? It is insoluble. So that does not dissolve in water. So that's going to be a solid. Now, do I hit the parameters? Letter C says if both products are soluble, then no reaction. Are both of those soluble? No. Okay, strontium chromate is insoluble. So a reaction will occur. Okay. Do I have my appropriate symbols on there? Yeah, I have them right here and right here. So I've stated which one is aqueous. I've stated which one is soluble. Okay? Now the final thing I need to do is I need to go back and look and say, okay, am I balanced? Am I balanced? What do you think? Yeah, I have a balanced chemical equation. So there is a double replacement number one. Two salts, two aqueous salts react and give two new salts, at least one of which is a precipitate, which means it's a solid. Any questions about our first one here? All right, awesome. Here's our second one, rubidium bromide. Rubidium bromide with silver fluoride. Once again, I'm not dealing with an acid, so I can see that I have a double replacement number one. I've identified my double replacement reaction. I've identified which type it is. So now I need to write rubidium bromide, silver fluoride. I need to swap cations. So I'm going to get silver bromide, and my second product is going to be rubidium fluoride. It's real nice and easy because all of them are plus ones and minus ones. So I've swapped my cations. I need to now check my solubility. So on my solubility chart, silver bromide, I'm going to come back up to the top, okay? Bromide is the second one in, so silver bromide is an I, okay? So that tells me it is insoluble. So besides silver bromide, I'm going to put that S. It's a solid. It's insoluble. Rubidium fluoride. Hopefully, rubidium fluoride is going to be soluble, okay? Fluoride is going to be 1, 2, 3, 4, 5, 6 over my rubidium. 1, 2, 3, 4, 5, 6 over gives me an S. So it is, in fact, soluble. So as I'm coming back here, that's going to be an aqueous solution, so my parameters are met. I have one product that is soluble, at least one that is a precipitate. Final thing, am I balanced? Yes, I am. Okay? Yes, I am. So there is our second example. Here's our third example. Sodium phosphate, silver nitrate. Once again, we're dealing with a double replacement number one. I'm not dealing with an acid. So I am going to swap my cations. Well, first of all, I guess I better write my formulas. So there are my reactants. Sodium phosphate. Sodium's a 1 plus, phosphate's a 3 minus. That's why I need 3 sodiums. Hopefully this writing formula stuff is becoming a lot easier for you than it was at the start. Now I'm going to flop my cations. So that's going to give me silver phosphate. Silver's a +1 also. And it's going to give me sodium nitrate. So I have swapped my cations. Now I need to check my solubility chart. So the first one I'm going to look at is going to be, excuse me, it's going to be silver phosphate. So I need to come back up, look to see where my phosphate, it's 4 from the right-hand side. So here's my silver. I go 4 over 1, 2, 3, 4. That gives me an I. So silver phosphate is insoluble. So I'm going to put that S there, saying that it is a solid. My second one, I need to check sodium nitrate. Nitrate is 1, 2, 3, 4, 5, 6 over. Where's my sodium? There. 1, 2, 3, 4, 5, 6 over gives me an S. So that is soluble. So my parameters are met. So I come back and say, okay, this is aqueous. So I have one that is soluble, at least one that is a solid. So my reaction will occur. Final thing I need to do is I need to balance my chemical equation. And I can see that I am not balanced. I need to, first of all, have a 3 here, because I need to have 3 sodiums on both sides. I need to have a 3 here, because my silvers are off. So once I do that, my nitrogen, or my nitrates balance up. So now I have a balanced chemical equation. Questions? All right. Moving right along. I have calcium carbonate and hydrochloric acid. Well, ladies and gentlemen, I now have my first acid I'm dealing with, correct? So I have to say whether it's a number 2, a DR 2, 3, 4, 5, or 6. So what am I dealing with? My acid is combining with what? Calcium carbonate, correct? So as I'm looking at my possible reactions here, what do you think? What do you think? Carly? A number 3, an acid plus a metal carbonate. Now, could that be considered a number 2, an acid and a salt? Is a metal carbonate a salt? Yeah. So it could be a number 2. However, number 3 is more specific, right? So I have an acid plus a metal carbonate or a bicarbonate giving me a salt, water, and carbon dioxide. Now, let's go back here and look. Calcium carbonate. Calcium's a 2+, carbonate's a 2-. Hydrochloric acid. Here are my acid rules. Now, the way I think of these, folks, the way I think of these is I still swap my cations. If I do so, I'm going to get calcium chloride, and I would also get carbonic acid. Well, the only thing, though, is that H2CO3 will break down into what 2 things? Water and carbon dioxide. Now, do I need to look at the activity series? Did it tell me to look at the activity series? Okay. Actually, let's look at the activity series, people. You tell me, do you see hydrogen on the activity series? Or excuse me, the solubility chart? It's not even on there, is it? So when I'm dealing with these acids, I don't need to worry about the solubility chart. The only time I worry about the solubility chart is when I have a decomposition number 1. And I guess I didn't put this. What did we say this was? A decomposition number 3? Or excuse me, a double replacement number 3, right? Now, last thing I need to do is go back and check, am I balanced? I'm not balanced, am I? I can see that I need to put a 2 here because I have 2 chlorines. If I put a 2 there, I have 2 chlorines, 2 chlorines, 2 hydrogens, 2 hydrogens, a calcium, a carbon, and 3 oxygens, so now I'm balanced. Agreed? Lead 2 hydroxide and hydrobromic acid. So, lead 2, hydroxide's a 1 minus. Hydrobromic acid, IC 1 or 3. This is acid rule number 1. So it's going to give me HBr. Now, once again, I'm dealing with an acid, so I have to determine which one I'm dealing with. So what do you think? 2, 3, 4, 5, or 6? Kira says 4, because I have lead 2 hydroxide, right? This, ladies and gentlemen, is a special type of a reaction. On your outline, it tells you it's a neutralization reaction, right? We will deal with these later on in the year when we're talking about acids and bases, probably 4th 9 weeks, okay? We will do, if we have enough time, we'll do a bunch of these reactions because they are what we call neutralization reactions. The acid is neutralized by the base. So we're coming back here, okay? Once again, it tells me that I'm forming a salt and I'm forming water. Well, watch what happens if I, once again, flop the cations. I get Pb, lead, bromide. Bromide's a 1 minus, so I need 2 of them. And I get HOH. Well, what is HOH? Water, right? So, there's where the water comes from. So now I have my salt, the PbBr2, and I have my water. I need to go through and I need to balance. I can see that I need 2 bromines, so I'm going to put that 2 there. Once I have 2 bromines, my lead's good. On my reactant side, I have 2 4 hydrogens, so I need to put a 2 here, and hopefully that balances out my oxygens, which it does. So I've just performed that neutralization reaction. Any questions there? Okay. Now, only got a couple more to do. I put this one on here for a specific reason. Silver bromide plus ammonium sulfate. Looking at these, this, I'm not dealing with an acid, am I? So this is going to be a double replacement number 1. So I'm going to need my activity series. Silver bromide. Silver's a 1 plus, bromine's a 1 minus. Ammonium sulfate. Ammonium is NH4, 1 plus. Sulfate's a 2 minus, so I'm going to need 2 of those. I am going to flop my cations. I'm going to switch my cations. So I'm going to get ammonium bromide and also silver sulfate. So I've switched my cations. So I've predicted my possible products. Now I need to check my solubility. I need to check my solubility. And as I do so, ammonium bromide. Ammonium bromide gives me an S. So that is an aqueous solution. It is soluble. Silver sulfate. My sulfate is the second to last one from the right. So where's my silver? There's my silver. It gives me an S S. Now, this SS tells me that it is what? Slightly soluble. If something is slightly soluble, it's very much insoluble, right? Only a little part of this will dissolve. So if you get an SS, we're going to treat that like it's an I. That's why I put this one on here, because this slightly soluble one is very much insoluble. So have I met my parameters? Yes, I have. So will this reaction occur? Yes, it will. Now, only thing I need to go back and do is balance. I can see that I need two ammoniums, I'm sorry. I need two ammoniums. That means that I need two bromines and I need two silvers. Now I have a balanced chemical equation. Questions? Now, here is the last one that we're going to do. I want you to do this, then I am going to do this. So you do it, and then we will work it on the board. Okay, let's take a peek here. Ammonium phosphate. Will react with nickel chloride. So this is going to be a double replacement, number one, because I do not have an acid. So I have two salts that are going to react to give me two new salts. So my first one, when I swap my cations, it's going to give me NH4Cl. So it's going to give me ammonium chloride, and it's going to give me nickel 2 phosphate. Now remember, don't switch that to nickel 3. Would it be easier to do nickel 3 phosphate? Probably, but don't switch that. Keep it at nickel 2. So nickel 2 phosphate is going to be Ni3 parentheses PO4 parentheses 2 to get my charges balanced out. So once again, did you write the correct formulas? Okay, naming is important. I need to go back. I need to go back and look. My first one is ammonium chloride. So I come back up to the top. I find ammonium. I find chloride. That is soluble. So I'm putting in the AQ. Nickel 2 phosphate. This has to be insoluble. So phosphate's the fourth one from the right. Where is my nickel 2? There's nickel 2. Fourth one from the right. 1, 2, 3, 4. It is insoluble. So have I hit the correct parameters? I have. So this reaction will occur. Now, the last thing I need to do is I need to balance this. Okay? And where would old Mr. Braun start with? Well, I would start with the phosphates. So if I put a 2 there, I balance my phosphates. Now I would balance my nickel. So I have my phosphates balanced, my nickels are balanced, and that gives me 6 ammonium and 6 chlorine. So if I put a 6 here, have I balanced this guy out? Yes. Did you get it? Let me see. Give me a thumbs up. Did you get it? Okay. If you didn't get it, do you understand why you didn't get it? Okay. Did you understand why if you didn't get it? All right. Now, that is all I have for you today, ladies and gentlemen.